Welcome back to Cradle to Grave Algebra. My name is Mark Gingras. Today I'm going to answer one of your questions about parallelograms and why the area of a parallelogram can be the same as the area of a rectangle with the same height and base. This question came in through comments, so if you have any questions, I will try to answer them in video form when I can. I'll put them in a different playlist though. It won't be in the normal playlist for the algebra series. That being said, let's jump right into it. The question came in about something along the lines of, is the parallelogram pictured here the same area of a rectangle with the same base and height? And the quick answer is yes. So I think a lot of you have probably seen the area of a rectangle being, let me change the color here, of being the length times the width. So if this was a rectangle, it's not the best rectangle. You know, you have your length and your width. It doesn't matter if it's L and W or W and L because of the associative property of multiplication. So your area is equal to length times width, right? Simple as that. That's a rectangle though. So what we're gonna have to do is trust me on this because you don't have enough mathematics to prove this, but I wanna use your intuition and see if you can come up with the, see if you can believe me, see if you trust me. Now it's trust but verify. Obviously, in order to prove this, you need a little bit higher advanced math, like trigonometry. So you need high school math. But now I want to show you this just visually, and then you can trust that it might work. Okay, so the area of a parallelogram. First, let's label it, and I will say that this is the length or the base. Let's call it the base. Let's do base. So B for base, and the height, I'm going to draw right here, all the way down. That's just saying the base times height or altitude or whatever the term might be. We'll just call it H, base times height. So again, I said that the rectangle was straight up base times height. So the area is equal to B times H. Don't worry about the capitalization versus non-capital. I should have been consistent, but I wasn't. Now, to believe me, what I'm going to do is I'm just going to translate part of this parallelogram back to the other side. So first, what I'm going to do is I'm going to draw a line. So we're going to draw a line down or up from this edge to the very top, something like that. It's not going to be perfect. Now I'm going to cut that piece out and I'm going to move it over here. I'm going to slide it. So I'm going to do that. Actually, I'll leave part of that red there so you can see the edge, and I'll hopefully capture the other part. So I'm moving it now. You can see I'm moving it. Moving, over. And you can see that that red line basically matches. Now, if I drew this perfectly and I moved it over perfectly, it would be the same base. You can see that base is here. Same base. The base didn't change. It still goes from here to here. It did not change. And the height did not change. The height is still the height. So I chopped off this section that was here, right? I chopped it off. So that area is gone, but I added it over here. So there's no net change to the area. So now if we just erase all this, get rid of it, right? You end up with a rectangle, base times height. That's really the intuition behind it. Now there's no secret or magical thing about it except for I can translate that piece, get rid of it, slide it over, and you get a rectangle, base times height. So the area of any parallelogram with parallel lines is the same thing as if it was a rectangle. Hope that helps. It's not the perfect answer because you need trigonometry and you need some high school math to prove it. But take my word for it that the formula works. And you're just going to have to take the word for it. So the formula for any parallelogram for the area is equal to the base times its height. Now you might see it as base times altitude or something else like that, but that's the general idea. And that's the same. Now a rectangle is a parallelogram. And so that just means that these lines, the two lines that go up vertical, they'll never touch each other ever because they go up for, if they went up for infinity and they went down for infinity, they would never touch each other because they're perfectly lined up. If there was a slight angle, they'd eventually cross. Same thing with the other two lines. So these two lines here, the horizontal lines, they're perfectly horizontal and they'll never ever cross because they're parallel. And that's the hence parallelogram. And a rectangle is just a special case or a subset of all parallelograms. Hope that helps. Send in your questions. I will try to respond as fast as I can because I know you guys are on a tight schedule as well. And I will see you in the next episode.